Grounding is required for both portable generators and outdoor heat pumps. For portable generators, the generator must be grounded in accordance with the National Electrical Code, or NEC, and the manufacturer's instructions. A ground rod must be driven into the earth near the generator. The generator's grounding terminal must be connected to the ground rod using a copper grounding wire with a minimum size of number 8 AWG. For outdoor heat pumps, each heat pump must be grounded in accordance with the NEC and the manufacturer's instructions. For heat pumps installed on a metal base, the base must be grounded. For heat pumps installed on a non-metal base, a ground rod must be driven into the earth near the heat pump. The heat pump's grounding terminal must be connected to the ground rod or grounded base using a copper grounding wire with a minimum size of number 10 AWG. Firstly, the grounding system should be tested to ensure that it is providing a low resistance path to ground. Secondly, the generator and heat pump should be connected to a ground fault circuit interrupter, or GFCI, to protect against electrical shock. Thirdly, all electrical connections should be made by a qualified electrician in accordance with the NEC. According to the National Electrical Code, grounding serves several crucial purposes. 1. It limits voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines. 2. It stabilizes voltage to earth during normal operation. 3. It facilitates overcurrent device operation. Grounding electrode systems typically involve connecting to a metal underground water pipe, a metal frame of a building, a concrete encased electrode, and a ground ring. The selection and installation of these electrodes must adhere to specific NEC guidelines. Grounding conductors, which connect equipment and the grounded circuit conductor to the grounding electrode, must also meet NEC specifications regarding size and material. The size of the grounding conductor depends on the size of the overcurrent protective device in the circuit. For instance, Table 250.122 in the NEC provides guidance on sizing equipment grounding conductors for various circuit ratings. Ground fault circuit interrupters, or GFCIs, are essential safety devices that protect against electrical shock. They work by monitoring the current flowing in a circuit and quickly interrupting the power if a ground fault is detected. Ground faults occur when current takes an unintended path to ground, such as through a person's body. GFCIs are required in various locations, including bathrooms, kitchens, and outdoor areas, to minimize the risk of electrical shock. Proper installation and testing of GFCIs are crucial to ensure their effectiveness. Regular testing involves pressing the test button on the GFCI to verify that it trips and interrupts the circuit. If a GFCI fails to trip when tested, it should be replaced immediately. Bonding is another important aspect of electrical safety. Bonding involves connecting all metal parts of an electrical system to create a low impedance path for fault current. This helps to ensure that overcurrent devices, such as circuit breakers and fuses, will quickly trip and clear fault. Bonding also minimizes the risk of voltage differences between metal parts, which can cause electrical shock. The NEC provides detailed requirements for bonding various components, including metal enclosures, raceways, and equipment grounding conductors. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning, utility switching, or other disturbances. SPD work by diverting excess voltage to ground, preventing it from reaching sensitive electronic components. SPD are available in various types and sizes, and they should be selected based on the specific application and the level of surge protection required. Proper installation of SPD is essential to ensure their effectiveness. They should be installed as close as possible to the equipment they are protecting and connected to a properly grounded electrical system. Regular inspection and maintenance of SPD are also important to ensure that they are functioning correctly. Electrical safety audits are comprehensive assessments of an electrical system to identify potential hazards and ensure compliance with safety standards. Audits typically involve visual inspections, testing, and documentation review. Qualified electrical professionals conduct the audits and provide recommendations for improving electrical safety. Regular electrical safety audits can help to prevent accidents, reduce downtime, and ensure a safe working environment. Lockout-tagout procedures are essential for safely working on electrical equipment. These procedures involve energizing the equipment, disconnecting it from its power source, and applying locks and tags to prevent accidental re-energization. Lockout-tagout procedures should be followed whenever working on or near electrical equipment to protect workers from electrical shock and other hazards. Training is a critical component of electrical safety. Workers who work on or near electrical equipment should receive comprehensive training on electrical hazards, safety procedures, and the use of personal protective equipment. Training should be tailored to the specific tasks and equipment involved and should be updated regularly to reflect changes in technology and safety standards. Arc flash is a dangerous electrical phenomenon that can occur when a fault in an electrical system creates a high-energy discharge. Arc flashes can cause severe burns, blindness, and even death. Arc flash hazards can be mitigated by implementing various safety measures, including using arc-rated personal protective equipment, designing electrical systems to minimize arc flash potential, and implementing lockout-tagout procedures. The NEC provides detailed requirements for arc flash hazard analysis and mitigation. Electrical protective devices, such as fuses and circuit breakers, are designed to protect electrical circuits and equipment from overloads and short circuits. Fuses are one-time devices that melt and interrupt the circuit when an overcurrent occurs. Circuit breakers are reusable devices that trip and interrupt the circuit when an overcurrent occurs. The selection and installation of electrical protective devices must comply with NEC requirements to ensure that they provide adequate protection. Electrical safety in hazardous locations requires special precautions to prevent explosions and fires. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Electrical equipment used in hazardous locations must be specially designed and certified to prevent ignition of these flammable substances. The NEC provides detailed requirements for electrical installations in hazardous locations. Static electricity can be a source of ignition in certain environments. Static electricity is generated when two materials come into contact and then separate. The buildup of static charge can create a spark, which can ignite flammable materials. Static electricity hazards can be mitigated by grounding equipment, using anti-static materials, and controlling humidity. The NEC provides guidance on controlling static electricity in hazardous locations. Electrical fires can be caused by various factors, including faulty wiring, overloaded circuits, and malfunctioning equipment. Electrical fires can be particularly dangerous because they can quickly spread and are difficult to extinguish with water. Class C fire extinguishers, which are designed for electrical fires, should be used to extinguish electrical fires. Regular inspection and maintenance of electrical equipment can help to prevent electrical fires. Power quality refers to the characteristics of the electrical power supply to equipment. Poor power quality can cause equipment malfunction, damage, and reduce lifespan. Power quality problems include voltage sags, voltage swells, harmonics, and transients. Power quality can be improved by using power conditioning equipment, such as voltage regulators, surge suppressors, and filters. The NEC provides guidance on power quality requirements for certain types of equipment. The electromagnetic interference, or EMI, is a disturbance that can affect the performance of electronic equipment. EMI can be caused by various sources, including radio transmitters, electrical equipment, and lightning. EMI can be reduced by shielding equipment, using filters, and grounding equipment properly. The NEC provides guidance on EMI mitigation techniques. Energy efficiency is an important consideration in electrical system design and operation. Energy-efficient equipment and practices can reduce energy consumption, lower operating costs, and minimize environmental impact. Energy efficiency measures include using energy-efficient lighting, motors, and appliances, optimizing electrical system design, and implementing energy management systems. The NEC provides guidance on energy efficiency requirements for certain types of equipment and installations. Renewable energy sources, such as solar and wind power, are becoming increasingly popular. Integrating renewable energy sources into an electrical system requires special considerations to ensure safety and reliability. The NEC provides detailed requirements for the installation of renewable energy systems. Proper wiring methods are essential for electrical safety. Wiring methods include the types of conductors, raceways, and enclosures used in an electrical system. The NEC provides detailed requirements for wiring methods, including conductor sizing, insulation type, and installation practices. Selecting the appropriate wiring method for a particular application is crucial for ensuring safety and reliability. Electrical codes and standards are constantly evolving to reflect changes in technology and safety practices. Staying up to date on the latest codes and standards is essential for electrical professionals. Code updates are typically published every 3 years by organizations such as the National Fire Protection Association, or NFPA, and the International Code Council, or IC. Continuing education and professional development are important for electrical professionals to maintain their knowledge and skills. Continuing education opportunities include courses, seminars, and conferences. Professional certifications, such as those offered by the International Association of Electrical Inspectors, or IE, can demonstrate competency and enhance career opportunities. Electrical system design involves planning and designing electrical systems to meet the needs of a particular application. Electrical system design considerations include load calculations, voltage drop calculations, short circuit calculations, and coordination studies. Electrical system design should be performed by qualified electrical engineers or designers. Electrical troubleshooting involves identifying and resolving problems in electrical systems. Electrical troubleshooting requires a systematic approach, including gathering information, testing components, and analyzing results. Electrical troubleshooting should be performed by qualified electrical technicians or electricians. Electrical maintenance involves performing regular inspections, testing, and repairs to ensure that electrical systems are operating safely and reliably. Electrical maintenance activities include cleaning equipment, tightening connections, and replacing worn components. Electrical maintenance should be performed by qualified electrical technicians or electricians. The use of personal protective equipment, or PPE, is essential for electrical safety. PPE includes items such as gloves, safety glasses, and arc-rated clothing. The type of PPE required depends on the specific hazards involved in a particular task. PPE should be inspected regularly and replaced when damaged. Electrical safety audits are comprehensive assessments of an electrical system to identify potential hazards and ensure compliance with safety standards. Audits typically involve visual inspections, testing, and documentation review. Qualified electrical professionals conduct the audits and provide recommendations for improving electrical safety. Regular electrical safety audits can help to prevent accidents, reduce downtime, and ensure a safe working environment. Working with electricity can be dangerous, but by following safety precautions and using appropriate equipment, it is possible to minimize the risks. Always follow safe work practices and consult with qualified electrical professionals when necessary. Proper grounding, as outlined by the NEC, is paramount for the safe operation of portable generators and heat pumps. Always adhere to these guidelines and local regulations to ensure electrical safety.